All right, 6.4, permutations and combinations. Now we're getting going. All right, here's where counting is going to get fun. So the first thing I want to do, we're gonna cover two big ideas in this section. One idea is called a permutation. The other one is called a combination. When you learn those two things, you're ready to start doing this entire section. The trick to these is they're not sometimes very easy to identify which is which. So here we go. First one. Now I'm telling you, this is a permutation. Let's talk about what makes this thing a permutation. Let's read it first. My class is going to run a race. There are 31 students in the class, and the top three finishers, first, second, and third place, will get prizes of $100, $50, and $5, respectively. How many different ways are there for me to award the prize? The prizes. So, what I'm saying here is, with all my different students running, whoops, that wasn't the word first. I could get a first place, second place, and third place finisher. So now if I was going to talk about my students, I could have student A, B, C. And even if I just had, let's just pretend for a minute, I only have three students. Does the order matter in which you finish this race? If you come in first or if you come in second, are those different scenarios? Well, yeah. Student A is really happy in the first race because they got first place, they get $100. Then in the second race, the second way of doing it, they got second place. So yeah, they're still happy they got $50, but not as happy as if they would have gotten 100. So in this case, we'll say order matters. The order in which you finish is important. So what we're going to do now is jump down to the combination problem, super schmooper fast. Okay, now take a quick read. My students are going to run a race. Oh, same thing. There are 31 students in the class, and the top three finishers, first, second, and third place, will get to go on a trip with me to Las Vegas. Okay, so to study probability, of course, that's it. Okay, nothing fun, just studying probability. All right, so first, second, and third place. Now, if you get first, student A, student B, student C gets first, second, and third, or if they got B, then A, then C. In that order, do they care that they came in first, second, or third? Are you really sprinting your hardest that you can possibly sprint knowing that you're going to get second place and not first place? Well, no, you don't care because it doesn't matter what place you came in, you get to go to Vegas. Student C is getting the same prize as student B. It doesn't matter who's first, second, or third. Does that make sense? So in this case, with combinations, the order does not matter. So the order is not important, right? Where back with permutations, the order matters. So when we say how many different ways are there of counting up my outcomes, what we're saying here is ABC or BAC are two different outcomes. These are different because they have different result. It creates a different result. Where with a combination, we're saying we don't care ABC or BAC. That is still the same outcome. So this is just one outcome. And any way I arrange these three letters, or these three students, however you want to look at it, it doesn't matter. This is all the same outcome. These three students are going with me on a trip to Las Vegas. It didn't change. These three students won the $100, $50, and $5, but the outcome does change because different students are getting the money. Okay? So, I hope that makes sense. So, that is the difference between a permutation and a combination. Permutations, order matters. Combinations, order does not matter. Now, the way I remember this is think of it like a pizza. When you order a combination pizza, they give you lots of toppings, right? Now, do they put them on in a specific order? Do you say to them, I want the pepperoni first, then the sausage second, and if I see them in the opposite order, I am sending that pizza back? Well, if you do, just to warn you, you're probably going to get some spit in your food, right? So, nonetheless, combination pizzas, the orders doesn't matter. It's going to have all those things mixed together. Do not order permutation pizzas unless you like saliva in your food. Okay, now, let's move along. How do you calculate this? How do you calculate the number of different options? Well, we have a nice little formula for this. What it is, N stands for the total number of choices to choose from, total number of objects to choose from. So the total number to choose from. So in this problem, I had 31 students, so therefore n is 31. R, on the other hand, is how many you're picking. So R is the, whoops, go away, number picked. So R in this case would be 3. Now, when we say picking, one idea here is we're going to pretend, and I hope I don't offend anybody. This is not my goal, is to use it in a derogatory sense. But I always like to think of it as just as if I was an almighty power and I have the ability to control these things. So it's not at random who's going to come in first, second, or third. It's not based off of athletic ability. It's based off of what I decide. So when I say the number picked, what I mean is just the number of ways for me to arrange these 3 students to finish the race. Okay, so I hope that makes sense. So now if I was going to fill this in here, the last thing here is a factorial. And if you don't remember what a factorial is, I'll explain that in 5 seconds. Just go with it. It looks like an exclamation mark. Okay, so it's n, so it's 31 factorial divided by 31 minus 3 factorial. So let's see, that would simplify to be 31 factorial over 31 take away 3. What is that? 28 factorial. Now, what factorial means is just going with your counting numbers, starting at the number you see down to the number 1. It's going to be all those values multiplying. So 31 times 30 times 29 times 28 times 27 times 20. I'm not writing them out. I'm stopping. Okay. Now the denominator, what I'm going to point out is 28 times 27 times 26, right? Well, what's going to happen here if you think about division is the 28 will divide with the 28, the 27 will divide it with the 27, the 26 will divide with the 26, and so on and so forth. So these will all divide away. So what we do if we're doing this by hand, what we're going to do instead is we're going to stop in our numerator at 28 factorial because that matches what I have in my denominator, and those two will just simply divide away. So you don't have to write out the whole thing. You're going to write out only the numbers up until the factorial in the numerator and the factorial in the denominator match. All right, so now I'm just left with 31 times 30 times 29. And there we go. So now, yes, you are probably going to want your calculator for the lots of the sections coming up here. The numbers get kind of big. So 31 times 30 times 29. And what does that result in? The wonderful number of, what, 26,970. So what that means is there are 26,970 different ways for me to arrange my students in a first, second, or third place. Great. Now, could you do this in your calculator? Yes, there absolutely is a button for this. What we're going to do here, let me show you the little calculator button. There we go. It's right here when you press math. Oh, sorry, excuse me, don't do that yet. I forgot. The calculator is using a slightly different notation. It's going to use the notation of 31p3. It means the exact same thing as up above, and so it could be thought of as NPR. So the first number you put in is the number of items you're choosing from. We're going to permute them, and we're going to choose 3. We're going to permute 3 of them. Okay. So you can absolutely type this in. So we're going to go, okay, I'm going to go over here. Whoops. We're going to go math. Oh, sorry, no, don't do that yet. I keep doing that. To do this in the calculator, you first have to type in 31. There we go. Now press the math button, and you'll see up here in the menu, there is probability. So we're going to arrow over to probability, and you will see now there's our NPR. And if you also look in line 4, there's your factorial right there. But so we're going to arrow down to NPR, hit enter, and you'll notice it fills it in for us. Now we have 31 permute, and we want to permute 3. I hit enter, and amazingly, it's amazing, the calculator gives us the same numbers what we got by hand. Who would have thought math works that way? Nonetheless, same answer. Now, are we going to do this in the calculator? No. Never do permutations in the calculator. Okay? Well, at least using the NPR button. It's silly. Because what I want to point out here is these are decisions and choices. And if you come at it from that perspective, if you just say, look, this isn't at random, I get to choose. Okay, I have 3 decisions to make. Who's going to come in first place? Who's going to come in second place? Who's going to come in third place? How many choices do I have for first place? Well, I had 31 students to choose from. Once I decide who's in first place, now I get to decide who's in second place. But I don't have 31 students because you can't win first and second. So now I only have 30 students left. Then I have 29 students left. This works every single time. The permutations button will not work in certain scenarios as we get more and more complicated. Just train yourself to think of it as decisions and choices. When you see permutations, just say, all right, here we go. First thing, what am I picking? Second thing, what am I picking? Move along. Okay? Now, combinations. Here we go. Same idea here. Same idea. We would have what? C of 31 comma 3. Right? And our n would be, again, 31 factorial over, now notice we have an r factorial, so it'll be 3 factorial times 31 minus 3 factorial. So it's basically the same function, it's basically the same idea as the permutations. The only difference here is I have this extra little 3 factorial down here. So I'm still going to write off all my numbers in my numerator to get to the 28 factorial. So it's going to be 31 times 30 times 29 times 28 factorial. And then I'm going to have my 28 factorial down here. What I'm going to do, though, is write out my 3 factorial because I'm going to write the smaller one. The logic is keep the big number, let those divide away in the factorial, numerator, denominator. Write out the small one, because now I'm just going to do a little bit of division very fast. 3 goes into 30 10 times, not 16. That looks like a 6. That was supposed to be a 10. There we go. And let's see, 2 goes into 10 5 times. So now this answer would be 31 times 5 times 29. And this is going to result in, we need our calculator. I can't do that in my head. 31 times 5 times 29. 4,495. There are 4,495 different ways for me to make groups of 3 students that are going to come with me to Vegas. Great. Now, can we do this in the calculator? Absolutely. And it's the same notation as before. We're going to do NCR, which would be 31C3. And this we will use our calculator for. This works every single time we have a combination. And it's the permutations, it's just so easy to do with decisions and choices. This one, not so much. So we're absolutely going to do 31C3, and you'll see we get the same number. Okay, so we have our 2 techniques. Let's do a quick example, and then we'll be done with the first lesson video. We'll just move on to examples. All right, how many ways are there for you to arrange Scrabble tiles of A, B, C, and D to make different 4-letter words? So if you don't know what a Scrabble tile is, there you go. That will be an example. So what they are is they're from a board game, and they just have letters on them. Don't worry about the little numbers. That's for the points. We're not going to be doing the points. But the idea is just you have these 4 Scrabble tiles, and we're going to arrange them to make different words. Now, ABCD clearly isn't a quote-unquote word. That's why I have it in parentheses, but we're going to count it. So that would be one arrangement. And I could take this and move these around and make it go maybe something like this. So now I have backed. That's another quote-unquote word, right? So how many different ways are there for me to arrange these tiles? Well, step 1. First thing we're going to do, identify is it a permutation or a combination. If it's a permutation, it means that the order in which I put these tiles is important. If it's a combination, then it means it is not. It's just the word backed is the same as the word, I don't know. I'm going to spell my favorite word ever. I was just cabbed. I don't know. So anyway, clearly, the order in which you put letters makes different words. So therefore, order is important. So therefore, this is a permutation. Very good. So how do we do permutations? We just simply say, how many decisions, how many choices? Well, I'm going to use all 4 spaces. I'm going to use all 4 tiles. And so for my first tile, whichever one I'm going to put first, how many choices do I have? 4. All right, let's say pretend I picked the C. Now, how many choices do I have left? 3. Let's pretend I picked the B. Now, how many choices do I have left? 2. Let's pick the A. Last but not least, I picked the last choice. So therefore, I have 4 times 3 times 2. Well, let's see. 4 times 3 is 12. 12 times 2 is 24. There are 24 different ways for me to arrange 4 Scrabble tiles. All right. I hope that helps. Watch the next videos. We're just going to keep doing examples after examples after examples.